If you recall, today in class, I had you graph this function, which was the original, on graph paper, and then I asked you to graph the derivative on the transparency. The reason that we graph the derivative is because it's the easiest way to see what the derivative will tell us graphically speaking. The key here is to note where the derivative is above and below the x-axis. Please remember that the derivative, the graph of the derivative, is a visual representation of the original slope. So notice, when the derivative is above the x-axis, our slope of the original is positive. So notice here, we have a positive slope. Here, the derivative is above the x-axis, we have a positive slope. When the derivative is below the x-axis, so from this interval, notice that we have a negative slope on our original graph. The first derivative test tells us specifically where our maximums and our minimums are located. Because think about it. Let's just look here. If I have a positive slope and then a negative slope, if you draw that with your finger, positive slope, negative slope, you're going to have a maximum. Whereas here, if you have a negative slope and then a positive slope, that means you're going to have a minimum. So the first derivative tells you from here, when I have a positive slope and then a negative slope, I'm going to have a maximum. Whereas here, when I go from a negative slope to a positive slope, I'm going to have a minimum. So the first derivative tells us specifically maximums and minimums. Not just where they're located, but what they are. So today we are talking about the first derivative test. This is section 3-3. We use the first derivative test to test for increasing and decreasing intervals. So to find maximums and minimums. We've already been doing this in class. You first take the derivative, set it equal to 0, and find all the times when it has a 0 slope or where it's undefined. We will use these numbers to create an interval number line. Then we will determine the sign of the derivative by testing values within each interval. If you recall from last year, you did this with rational inequalities. Remember this, if the derivative is greater than 0, then we are increasing, because the slope is increasing. If the derivative is less than 0, then the original function was decreasing because the slope was negative. Let's do the very first example. We're going to identify the open intervals on which the function is increasing or decreasing. We will then sketch a graph of the function. So the first thing we should do is take the derivative. So first, we're going to take derivative. So we have y prime equals, now we're going to have to use low d high minus high d low over low squared. So low d high minus high d low over low squared. So I took the derivative. I'm going to clean up the top a little bit. I get 2x squared plus 2x minus x squared all over x plus 1 squared. And then I'm just going to combine my like terms. Now we're going to find our critical numbers. Remember, this occurs where the function is when the top equals 0. That will be where we have tangent lines with a slope of 0, so maximums or minimums, and then also where the slope is undefined, so where the graph is undefined, and that is where the bottom equals 0. So we're going to find critical numbers. So I'm going to set the top equal to 0. These are going to give me my maximums or minimums. I'm also going to set the bottom equal to 0. And this is going to be where the graph is undefined. So where it has a vertical asymptote. Over here, I can factor out an x. And I find that x equals 0 and x equals -2. Over here, I get x plus 1 equals 0, so x equals -1. This is where it's undefined. So this is where the graph is undefined. These are maximums or minimums. And we're going to figure out what they are specifically by doing the first derivative test. So now we're going to test our intervals. I'm going to have, we're going to break it up into -2, -1, and 0, because those are the three numbers. Now, in order to test it, I'm going to pick numbers within these intervals. So remember, this goes to -infinity, this goes to +infinity. I'm going to pick not the numbers given, but the numbers within the intervals to see if it's positive or negative. So I'm plugging it into the derivative. So I'm picking numbers and plugging it back into the derivative. If you need to, use your calculator. So like over here, I think I'm going to pick the number -3. Here, I'm going to pick the number -1.5. Here, -0.5, and here I'm going to pick the number 1. And then I'm going to plug everything in. So if I plug -3 into this equation, I find that I get a positive number. When I plug -1.5 into here, I find that I get a negative number. It doesn't matter what the number actually is, it's just the sign that counts. When I plug -0.5 into this, I find that I also get a negative number. And then when I plug 1 into the derivative, I find that I get a positive number. So if I use arrows, it's going up, then it's going down, and then it's going up. These tell you specifically if you have a maximum or a minimum at specific points. Here, at -2, since we're going up and then going down, that's going to be a maximum. This doesn't have anything, we don't change signs. Over here, because remember this is undefined, here we're going down and then going back up, so this is a minimum. If I were to sketch this, very, very basically, I have something, it's undefined, at x equals -1. I know that I have a minimum somewhere at 0. I know that it's going to come down and it's going to be a minimum. It's going to be going down and then up, I guess, something like that. And then over here, it's going to be going up and then down. And you can use your calculator to help you out. There must be some type of oblique asymptote. So there you go. You find your critical numbers, you create a test interval, you plug numbers within the interval back into the derivative, and if it's a positive number, then it's increasing. If it's a negative number, then it's decreasing. Notice that this makes a maximum, this makes a minimum. And that's how you can tell, using the first derivative test, if you have a specific maximum or a specific minimum and where it's located. Let's go on to example 2. It says find the critical numbers of the equation. So let's do that first. Remember, to find critical numbers, you're going to take the derivative. So I'm going to take the derivative of this. Remember, this is the power rule. So I'm going to bring that down. And then the derivative of -4 is 0. So this is our derivative. We'll set the derivative equal to 0. And solve. This goes away. We get 0 equals x to the power of -1/3. But if you think about it, that's a negative, so it's really 0 equals 1 over x to the 1/3. So my critical number is x equals 0, and it's also a discontinuity. We're now going to find the intervals on which the function is increasing or decreasing. Remember, this is our only critical number, so when we create our test line, our test interval, that's going to be the only number on the interval. It's kind of nice because now we can pick really easy numbers. Let's pick -1. Let's pick +1. When I plug -1 back into the derivative, so back into the derivative, I get a negative number. When I plug +1 back into the derivative, I get a positive number. Again, the number itself doesn't matter, it's just the signs that count. So we know that it's going down, and then it's going up. Since it's going down and then up, that means this is kind of like a minimum. It's kind of a minimum. But really it's a discontinuity. So there could be a hole, there could be a vertical asymptote. Let's use the calculator to find out exactly what's going on right there. So let's graph. X to the power of 2/3 minus 4. If you look at it, it looks like there's a cusp right there. And that's why when we take the derivative, that it's not actually differentiable. So it's kind of a minimum, but it's a minimum because of a cusp. So at 0, we know the graph comes down, cusps, and then goes back up. So notice it has a negative slope and then a positive slope. And right there is a cusp. And there you have it. You've actually, with part B, you actually answered part C, because we said right there what they are. Tomorrow in class, we're actually going to do some homework on this, so please come prepared. Have a good night.